Work. Good. Okay, so 6B is focusing a lot more on differentiating exponentials. So here are the, because it won't always just be an e to the x, right? So it could be e to some little function. Maybe it's a 2x. Maybe it's an x plus 5. Some little function up here in the power. So when there is something a little bit more unusual up here, what you do is you differentiate whatever that is. The derivative comes to the front, but the exponential part stays the same. You don't subtract one from the power. Never subtract one from the power of exponentials. Okay? So the e to the f of x is still an e to the f of x here. The only thing that happens is that derivative comes to the front. That's the extra bit. Okay? Then there's this one. If it's y equals a to the f of x, so this is not an x, this is not e, right? So this one, it is log base a, the derivative of whatever the function is, a to the power of f of x. That is not going to come up very often because we're focusing on exponentials like e to the x, but we do have that one there as well. So question 1, differentiating. Lots and lots of differentiating. So let's put our y dash there for derivative equals. The derivative of e to the negative x, the derivative of the negative x is negative 1. So the negative will come down the front and then it will stay e to the negative x. Then I move on, so I go plus. Now let's differentiate the second term. Derivative of e to the x is e to the x. That's it. We're done. Next. Question B. Any numbers sitting out the front? So this 3, it's just a lovely little spectator out here for the moment. Leave it sitting out the front. The derivative of the power is 5. So times the 5 down here. Keep the exponential with the same power. And then you just times that 5 with the 3. So it's 15e to the 5x minus 2. Question C. Looks yucky because we have powers and fractions in powers. Who cares? We can still do it. So, derivative of the power is negative a third. Then leave the exponential with its power exactly the same. That's it. Question D. Have a bit of a problem with the thirds in there. So I'm going to have to change that to be fractional powers before I can differentiate. So what do you think the square root of e to the x is? E to the power of? Yeah, so technically it's e to the power of x, which is all to the power of a half. But you may just want to times that half and that x together straight away. So half x. Can I do that straight away? I don't think we'll have room for much more. So let's just go e to the power of half x. So this one here is also going to be e to the power of half x, because on the bottom I want to bring it up and it will become e to the power of negative a half x. Okay, now that we've done some fiddling, let's differentiate it. So y dash equals the derivative of the power, which is a half, comes down the front. Keep the exponential, keep the power. Second one, derivative comes to the front, which is negative a half. E to the negative half x. Now, if we've been really good, what should I do here? Put it back into third form. So, that half x is square root of e to the x. So square root e to the x, and the half, I'm just going to put it over 2. You can put it out the front, that would mean the same thing. Okay, then minus the 2 is going to go on the bottom again, and the e to the negative half x, negative means put it on the bottom, make it a square root of e to the x. What's going to go on the top? A 1. And that's it. Okay, let's keep progressing. Question 2. Differentiate. Y equals e to the 3 minus 2x cubed. So y dash equals, what's the derivative of the power? Minus 6x squared. Okay, that's the derivative of the power. Then you keep the exponential e to the 3 minus 2x cubed. Power always stays the same. Okay, what should I do with question B? Well, that big power of 6 caused me a bit of a problem. This is the chain rule. Okay, so when we do the chain rule, the 3 at the front is going to stay at the front. It's just sitting there. We bring the power down, so we times the 6. The power comes down. Then you multiply by the derivative of the bracket. What's the derivative of this bracket? Comes from here, moves with just the 4. 4e to the 4x. Okay, so that's the derivative of the bracket. Then you keep the bracket, which is e to the 4x plus 5, and subtract 1 from the power, so it becomes a power of 5. Do you remember it now? It's just weird with exponentials in there, but we've done this plenty of times before. I can't talk loud, you have to be quiet. 3 times 6 times 4 is 72, e to the 4x, and then e to the 4x plus 5 to the power of 5. All right, next. Question 3. What is the problem with question 3? There's a power in the x, that always happens, for the e to e. Yep, be more specific. What rule am I doing here? What kind of question is, what did you say? Product rules. Another thing on the exam, some people did not identify that there was a product rule and a quotient rule in those lists of differentiation things you had to do. Okay, so the product rule in short form, not the long one on the formula sheet, is y dash equals, whoops, that was meant to be a v, vu dash plus uv dash. That's your formula. So in A, u is going to be the x squared and v is going to be the e to the x. They are two x things that are multiplied together. Now I differentiate both of them. U dash is 2x, v dash is e to the x. Now, y dash equals, here we go, I'm not going to rewrite the formula, I'm going to put it straight into here. So v times u dash, going across this diagonal here. So it's 2x times e to the x, 2x e to the x. Then plus the other diagonal, that one times that one, is x squared e to the x. Happy with that answer? Or you could factorize it, because there is quite a few common factors in there. You could bring out an x e to the x. From the first term, that would just leave a 2. And from the second term, you'd have an x. Okay? B is still a product rule. These are both product rules. Okay, it's a little bit messier in the exponential part. So let's do it again. U is going to be what? 2x. V is going to be e to the 3x plus 4. All right, differentiate them. U dash is 2, good. V dash is 3e to the 3x plus 4. Good. All right, into our product rule. Y dash equals VU dash, checking that diagonal, going across here. We're doing 2 times the e to the 3x plus 4. Then timesing the u with the v dash, we have 2 times 3, which is 6x e to the 3x plus 4. Okay, again, happy with that answer. Or you could factorize it. So you could bring out a 2e to the 3x plus 4, which would leave a 1 plus 3x. So if those are product rules, what's question 4? Quotient rule. So the quotient rule, y dash equals, got it memorized? VU dash. Yeah, so in your VU, the only difference is that it's now a minus and over squared. So U must always be the top or the bottom? Top. U is the top. So U is e to the 3x. V is x. U dash is yes. And V dash is 1. Alright, so here's my y dash equals V times U dash will be 3x e to the 3x. Then minus, go the other way. 1 times e to the 3x is just e to the 3x. Over v squared, which is just x squared. And you could factorize that also if you wanted to. So you could bring the e to the 3x out. 3x take 1 over x squared. B, quotient rule again. U is e to the 2x. V is 2 minus x to the 4. U dash is 2e to the 2x. V dash is minus 4ex, cubed. This is the biggest thing people have problems with, is they go, exponential, the power doesn't change. But a normal x, normal differentiation is. Don't mix them up. Okay, into our rule. Y dash equals V times U dash. So I'm going to put the 2e to the 2x first, so that I can put brackets around the 2 minus x to the power of 4. Then minus times in the other way. Ooh, it's another minus, so let's change it to a plus. 4x cubed e to the 2x over v squared for the bottom, which is 2 minus x to the 4 squared. What should I do with that? Expand out the top, see if there's any like terms. So we would have 4e to the 2x minus 2x to the 4e to the 2x plus 4x cubed e to the 2x. There's no like terms. Over 2 minus x to the 4 squared. There is a common factor in all three of them though. You could factorize a 2e to the 2x out of all of them. You don't have to. Alright, so that's 6b done.